Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Time for another segment on building this new ST70 kit. If there's any parts or tools that are specific to this segment or the build in general, check the description below. Can't guarantee that these links are going to be good months from now, so if they're dead, when you go to look, you may have to go hunt these parts somewhere else. Don't email me. I'm not going to hunt them up for you. So, that said, let's get busy building. Okay, so now it's time to start working on the DC wiring. And our DC comes off of pin 8 of the rectifier tube and then goes through this 4 capacitor filter network. And I'm going to be wiring this up a little differently than the instructions call for. The instructions want you to run this 40 UF cap right after the rectifier tube. And I personally think that is not a good idea with a tube rectifier. Yeah, it can be done. It is within spec, but it really puts a lot of stress on the rectifier tube. I feel like unnecessarily. We can achieve very similar levels of filtration, and we actually end up with more capacitance after the choke, which is closer to the tubes where they're being used, by wiring it up the way I'm going to show you. And so we're going to be hooking up the 20 UF, which is the unmarked pin, to the rectifier tube output. Then we're going to be tying the 30 and the 80 together, which will give us 110 UF of capacitance after the choke. And then finally we're going to have the 40 UF after a resistor as the RC or resistor capacitor filter for the front end board. So the other thing that I did is, you can see here's the cap the way it comes. Let's get the sticker on it and stuff. I spend a little time and polish it up a little bit. And, you know, it's not, is it mirror super polished? No, but it's got a nice finish to it. The other thing you might want to do for appearance sakes is look and see if there's any dents. Like there's a little tiny one right there. And put that towards the back, because really you can run these wires any way you want. But ideally you want to put this 20 UF pin towards the back, which is what we're going to do. So we come through here and put our cap through the chassis like that. And you can see I've already tied the little triangle pin and the one that's kind of a D-shaped symbol together with this piece of wire. And that's the 30 UF and the 80 UF. So they're going to be tied together. So first thing you do is mount this thing, and to do that you want to make sure it's pushed up against the chassis, and then you grab these little tabs, and we're going to be turning them clockwise. So you pull up on them and twist, just like that. And then you want to like push the cap towards the back, pull up, and twist. And then we'll do the same thing in this front one. Pull up and twist. And then finally, in this back one, pull up and twist. And at this point, it should be tied up against the chassis. If it's not, you might need to get down closer to the cap and twist. And get it where it's really clamped down to the chassis, because we don't want this thing buzzing. And there we go. It's nice and tight. So the next thing you have to do is we need to run a piece of wire from this little tab here to this ground terminal to make sure that we have a good ground from the body of the capacitor to our star ground point. Even though it's attached to the chassis, we want to run a piece of wire as well. And so I get some solid core wire, strip back a long enough piece to go between the 2 points. I'm hoping I've got enough room in this hole to add one more part, which I'll show you in a second what that is. And we might have enough room left for my last little part that I'm going to be adding here. And this is a part that is not in the instructions, but I feel like is really important. And it's called a bleeder resistor. And the purpose of this resistor is so that if you power the amp on, or when you power the amp on, and after you shut it off, there's a path from the high voltage capacitor lead to ground through a fairly high resistance. We're using a 510K, 470K, anything like that. It needs to be about a 2-watt resistor. And it's going to go between this terminal and ground. And that way, when you turn the power off, there's a pathway to drain the voltage that's stored in these capacitors to ground. And if you don't have a bleeder resistor like this, especially if you powered the amp up with no tubes in it, and there's no current being drawn off of this portion of the cap, the voltage will just sit there for a long period of time. And even with the tubes in place, you're relying on the tubes to continue conducting until this capacitor drains, which the tubes may stop conducting before this capacitor is drained, and there'll still be, pretty good bit of voltage sitting there on it that could end up shocking you if you went inside the amp to work on it after the cord was pulled out of the wall. So I'm hoping that looks like there's just enough room to get that in the same terminal or the same tag point. And so we're going to put this little resistor just like that. And this is why we didn't solder this up earlier. It's because I want to attach as many things as possible to this ground point so that we got some room on this other side to attach the stuff we got to hook up over there later. So there goes that guy. And we can reach up behind here, bend this over, and there's our bleeder resistor. Let me zoom in a little bit here since we're going to be kind of focusing on this. And there we go. There's our little bleeder resistor. And it sits in there just like that. So we're now ready to solder this terminal up, because we've got just about every possible ground that we could fit in that one in there now. Oop, let me turn my fan on. When this is a connection, you want to make sure, this ground stuff, you want to make sure you get a really good solder joint on. Okay, so now we got the case of that capacitor grounded. We've got our bleeder resistor grounded, and this wire goes over to our center tap tag strip for the heaters, and now that's grounded. So the next thing we want to do is we want to pull the rectified DC positive voltage off of pin 8 of the rectifier tube. And it's going to come over here, and it's going to connect to this terminal here. And then we can go ahead and figure out the choke as well while we're doing this. And the choke is going to go to this terminal and then to that terminal. So the rectified DC is going to come off of this pin, go to the 20 UF, which is the unmarked one, which is the first filter from here to ground. Then it goes through the choke comes back out, goes to this terminal, which is the 80 UF, which is tied to the 30 UF. Here's the ground through the bleeder resistor to bleed off the voltage. And then we'll have this wire coming over from the output transformer, which will connect to that terminal. And then the other one will come over and connect to this terminal right here. So let's go ahead and get the choke wires connected. And then we're going to run this positive wire, or the DC wire, from pin 8 over to this pin. And we're going to, again, use the 3D space in the amp to try to keep it away from this AC wiring as much as possible. But we're really not running it anywhere near any real high current wiring, so it shouldn't be an issue. Then we can solder this guy in place. Actually, I'm going to get this wire out of my way so I don't accidentally cook the insulation, and attach the choke and the lead for the rectified DC coming off of our rectified tube. So then we've hooked up the high voltage DC coming off the rectifier tube and one leg of the choke to this terminal. So then the voltage comes off the other side of the choke and feeds the other side of the filter cap, or the other side of our, it's called a CLC filter, which is a capacitor, an inductor, and then another capacitor. And actually, I think I'm going to shorten that lead up a little bit. It's a little on the sloppy side. I do have to apologize here. The memory card on my camera filled up and it quit recording, and I didn't realize it until I'd already connected some other stuff. So let me go over what we did. The last thing you saw was I was connecting this second choke wire. So we took this wire, which is the B plus or positive wire for the output transformer, comes over here and connects to this terminal here along with the output of the choke. Then we have this jumper wire that goes across these two terminals. We had our bleeder resistor that I showed you hooked up to this one. We also have this 2.2K 3-watt resistor that's the second RC filter that goes up to the driver board. Goes from this terminal to this terminal. And then we have the other red positive wire from this output transformer that comes across and is also connected to this same B plus wiring that this other side is. I mean, they're connected together with this jumper here. And so the flow of the electricity is the rectified DC off the rectifier tube that's, you know, pretty noisy, comes up here, goes to the 20 UF cap, then it goes through the choke back to the second cap, which is the 80 and the 30 tied together. So it's 110 UF or microfarad. And then we have this 2.2K that goes to this 40 UF cap, which is the RC, which is resistor capacitor filter. That then this is the power that we pull off that goes to the driver board. So we didn't miss too much there, and you just kind of missed me soldering these two connections, or, you know, when I tag this one down. So the next thing I'm going to do is I'm going to get set up, and we're going to come in here, we're going to zoom out, and we're going to power the amp up again, and this time we're going to be checking the high voltage DC and make sure that we've got, voltage here, here, there, and that we've got that our high voltage DC on the screen and the plate of all of the output tubes. So let me get that set up. We'll come back and do some voltage measuring. Okay, we got our rectifier tube plugged in. We've got our amp plugged into the wall. We've got our ground wire here hooked up to the multimeter, and then we have the positive clip on the little jumper wire between the two terminals on that capacitor, which is after the choke. And we're going to power the amp on. Like I said, we got the rectifier tube in. We don't have any other tubes in the amp. We're going to power this thing on and see if we get high voltage DC on our power supply. And you'll also get to see, we just turned it on, and you'll get to see how slowly the voltage comes up using these indirectly heated rectifier tubes. And there we go. And there's 500 volts, and this is unloaded. So we know we've got our voltage there, and we're going to turn that off. Once we get our load on the tubes, it's going to bring that power supply down a lot. Probably under 450. We won't know till we put all the tubes in and get them all biased up. And now you can see we've got the power off, we got the cord unplugged, and we still got 350 volts inside the amp. And if we didn't have that bleeder resistor over there, it would have just sat there at 500 volts for God only knows how long. But you can see the bleeder resistor, even with no load on the system, it's going to pull our voltage down to a safe level without us having to do anything as far as like draining capacitors or whatever. It basically is a self-draining capacitor deal. So the other thing we can do after this, and I'm probably going to do this off camera, is check and make sure we've got voltage on all of these other output transformer leads to the tubes, and don't want to leave it on too long with it at over 500 volts unloaded. That's really pushing what that filter capacitor can deal with, but for short periods of time it won't hurt anything. So you can either use a probe like this with one hand behind your back and make sure you never have both your hands inside the amp ever. And that way, if you do something stupid and you end up touching something, at least it's not going to go through your body and across your chest and across your heart and make your heart stop. That's what will kill you. So if you are ever inside of an amp using a probe like this, insulated probe, make sure you keep your other hand behind your back and don't touch the chassis with any other part of your body. Don't have your hand like on the choke while you're touching something, because it'll jump through your fingers and shock the crap out of you. So if you're new to this, probably best to just let the amp drain down between each test and use this little clip lead, and that way you don't have any hands inside the amp or have your hand inside the amp. But I'm going to check the other voltages. I'm sure they'll be fine. The main thing is you just want to make sure you've got 500 volts sitting on there unloaded, and then you've got everything wired up right. So I think it's a good place to wrap this up. So that wraps up another segment of this ST70 new kit build. Want to add that this is not sponsored by Tubes for Hi-Fi, nor do I have any affiliation with them. This kit was drop shipped to me by a viewer that commissioned me to build this for them. Now, I don't normally do like kit builds professionally, so yeah, I may or may not be willing to do it in the future. We'll see what that's all about, but for now, we're just doing this one for the channel and for some fun. I want to thank all you Patreon supporters and folks that make donations at my website. If you find this information useful, please consider joining my Patreon or making a donation at my website. It really helps fund future projects and keeps this channel going. I also want to thank you regular viewers and especially you subscribers. If you haven't subscribed yet, please click the subscribe button. It's not a big deal to do. It doesn't cost you anything, and it helps the channel grow and other people see my fun content. So that's going to wrap this up. Until the next segment, have a nice day.